Okay, so we're going to look at a problem with angular kinematics. It says a wheel rotates with a constant angular acceleration of 3.5 radians per second squared. If the angular speed of the wheel is 2 radians per second at the start, how many revolutions does it make after 2 seconds, and how fast is it going at the end of that 2 seconds angularly? Okay, well, this is a kinematics problem, so we're going to follow that kinematics process. First, thinking about what is the object that we care about. Well, it's the wheel that's rotating. And this is rotation, so we're going to think of rotational kinematics and our starts and stops and all of that. All right, so we're interested in the change in angle. So this is how many revolutions. Remember, how many revolutions. All right. And if we think of theta initial being 0, so it starts at our start point, how many revolutions does it go is going to give us that theta final. Our initial angular speed, we're told, is 2 radians per second. We don't know our final angular speed. Our angular acceleration is 3.5 radians per second squared, and our time is equal to 2 seconds. Okay, so how many revolutions does the wheel make? What is our change in theta? Well, we want to remember that these are just like our kinematics equations. So our delta theta is equal to our initial angular speed times time plus 1/2 our angular acceleration times time squared. So if we think about this delta being theta final minus theta initial, we've talked about that as well. All right, so now it's just a matter of kind of plug and chug here. So we have our delta theta omega initial was 2 seconds plus 1/2, and we're told that it's speeding up times 2 squared. And so we find that our delta theta is 11 radians. But that doesn't tell me how many rotations, that just tells me the radians. So I have to do that conversion between radians and revolutions. So we know that 11 radians is what we're starting with. We want revolutions, and we know that there is 2 pi radians in 1 revolution, and we find that we get 1.75 revolutions or rotations in that amount of time. All right, good. So this is part A. Part B asks us how fast is it going after those 2 seconds. So we look again to our kinematics. We're now interested in this value. And we know that the final angular speed is equal to the initial angular speed plus the angular acceleration times time. So our initial angular speed was 2. Our acceleration is 3.5 times that 2 seconds. And we find that our final, 3.5 times 2 is 7, plus 2 is 9 radians per second. And of course, I could turn that into revolutions per minute, sort of thinking about that same conversion we've done before. All right, so identifying we have a kinematics problem here, following our kinematics process, just using rotation instead of translation. Good job.